Hello and welcome. In this example, we're going to look at what our waveform that they gave us here is going to do for our cycles in a very specific time frame. Right, so first thing we need to do is figure out how long are our cycles, because once we figure that out, we can tell it how many times that happens in this length of time, right? So we just need the time factor for our cycles, and we know that's period, and that is a t value. So we need t equals, and they gave us frequency up here, and so we can use that. We can say t equals 1 over f. That's our frequency equation. And that can be used to determine our cycles. Remember, our cycles are equal. One full cycle is equal to one period. So that's what we're using here. So let's calculate that. We'll say that this is equal to, we'll put it into our calculator. We have 100,000 hertz. So that is 1 over 100,000. We can plug that in. You can also put it into notation still. 100,000 there gives us 10 microseconds. Move that over by 1, so 10 microseconds. So that is how many times we can cycle one cycle, right? And now we need to know how many times does 10 microseconds happen in 8 milliseconds. And so that's our next stage here. So we'll take our 8 milliseconds, that's actually a larger time, and we'll divide it by 10 microseconds. Send this out, and we'll say that our 8 milliseconds, we'll put that in as milliseconds, 0.008, move that over by 3, right? And we'll divide that by our microseconds. We'll plug that in engineering notation because it's a little bit easier that way. 10 times 10 to the negative 6, right? Micro is negative 6. So we end up with 800 cycles that can happen in 8 milliseconds. Right? This doesn't have any notation on the end, it's just cycles, right? Because it's the number of times that our period occurred, right? And that period is the same as how many cycles that frequency can generate also. All right, let us know if you guys have any other questions.